So please be aware of that. Okay, so what we've done so far is we've had a couple of check-ins. We've had a few technical difficulties, and I'm still working through some of those on my end. But I want to go ahead and keep up with our check-ins as much as possible to see where you guys are. So if any moment that you're dropped from this session and can't get back in, or if I am dropped for whatever reason, and 5 minutes have elapsed and you haven't been able to get back in, or I haven't been able to get back in, then just look for the recording on your Canvas site somewhere. But sometimes we do have some technical difficulties, and which can cause some problems from time to time. Okay, so where we are. So the purpose of these meetings, I just want to spend some time to go over that again. Why do we have these sessions? The purpose of this meeting is to review key information to you guys about the topics that we're covering in a particular week, and provide you the opportunity to have some questions answered live, hopefully. So by doing this, hopefully we get a feel for some of the things that we can do in a face-to-face class, even though most of this class is being done via online technology. So what we're going to be focusing on is what we're doing now this week, sort of a summary and overview, and then allow some time for you guys to for me to answer some questions that you may have. At this moment, as you can see here, using your chat feature, just send me a note that you are present, and we'll use this somewhat as a attendance, and this will turn into some points a little bit later for you guys as well. So the first thing I want to do is to go over real briefly just some information that I always want to remind us of, and that is the course flow. So I want to keep reminding you of the types of assignments and activities that we have in this course, excuse me, and this is key for us. And so the idea is that we need to understand that you're going to be responsible for reading the chapters in the textbook and any other supplemental materials that may be provided for you. As you're working through that material, you have the opportunity to complete the quiz homeworks, which are going to be on the material or the chapters that we're going over. There are also lecture notes, which are available to you, and those are basically the presentation slides, and you can use those to annotate and for your own notes to help you study. And then there's going to be video lectures, as well as discussion boards related to those video lectures as well. There are also course videos like from the Crash Course Psychology that you should watch that will help to supplement your understanding of the material. And from time to time, as listed in the course syllabus, there are discussion forums as well. Normally what I attempt to do as a unit is about ready to be wrapped up, I will have a review session and or provide for you guys a study guide that you can use to help prepare you for the upcoming unit test. So we just finished a unit about a week ago, and I want to go over real quickly the exam results for that. So that was exam number 2, and in exam number 2, we focused on a variety of topics. Chapter 3 on consciousness, chapter 4 on developmental psychology, and chapter 5 on sex and gender. So there were a few items that I wanted to touch base on based on the review of your performance in that particular exam. First, you guys performed really well. Overall, there was a 91% average for both classes. It was a slight dip from the scores from the very first exam. So it wasn't much of one, but there was a slight dip, but you guys are still performing at an A level overall. So the few items that there were some issues with, and what I mean by issues, I have a process that I go through. I look at all the test items and I see how many people missed particular items. If more than 70% or so people missed a particular item, I look at that item carefully and see where there might have been an issue. And these are some of those items that were missed at least 70% or greater by the people who took those particular exams. So first, I want to cover some of these items. The first is dealing with homosexual orientation. And again, remember, we have a variety of types of orientation. That's the level or degree of attraction that someone has for someone of the same or opposite sex. And there was an item that talked about changing homosexual orientation. And the basic premise is that because of it being a biological, or mostly biological from the research that's been done so far when it comes to one's sexual orientation, it is seen to be something that is very unlikely to change. So there's really no behavioral process that one can go through to try to change someone's sexual orientation. The other item that caused a little bit of an issue too dealt with infantile amnesia. And remember, this is the idea that anything before 3-4 years of age or so, you generally cannot recall. If you recall some sort of event that occurred during that particular time of your life, most likely you have a false memory that someone has told a story about you so often that you sort of manufactured a memory about that. Because most oftentimes what we see is that people are suffering from infantile amnesia. And that's best explained because the hippocampus, and remember, the hippocampus is very key to establishing long-term memory for us. The hippocampus is not fully mature yet in other areas of the frontal lobe. So this is one of the reasons why we tend to have this infantile amnesia. We just don't have the mechanisms in place yet for us to be able to store that information so that we can retrieve that information later from our long-term memory. The other item dealt with aggression. I'm not quite sure why there were so many who missed this particular item. But aggression is defined simply as in psychology, as a physical or verbal behavior intended to hurt someone. I guess maybe the issue could have been that most people think of aggression as being somewhat physical, but that's not always the case, particularly when it comes to relational aggression. Aggression can be done verbally. You can hurt somebody verbally, and sometimes that can even hurt more so than a physical harm. So I don't know why that particular item, but wanted to make sure we had some clarity on that. The other thing that we focused on too dealt with women and their tendencies when women are more likely than men to tend and befriend as a way to cope with stress. What this comes down to is the fact that when there's a lot of stress in the environment, men and women tend to respond to that stress somewhat differently. Women will seek out their friendships, their buddies, to talk with them and share with them, and men are less likely to do that. Usually men will bottle that anger in, or unfortunately drink alcohol or something of that nature in order to deal with stress. So we do see that gender difference between men and women. And finally, the last thing I want to cover deals with drug use. There was an item on the test that dealt with a little scenario they gave you and asked whether or not this person suffered from mild, moderate, or severe disorder. And what it comes down to is uh, people use drugs, that's for sure, but not everyone is going to be considered to have a disorder simply because they are using drugs from time to time. And what was discussed in that particular chapter is there is a scale that can be employed with a bunch of behaviors that are listed, and depending on how many items that you select from that list, it can categorize you as mild disorder, moderate disorder, or a severe disorder. So those were some of the items that I wanted to just cover a little bit to see if there was any more clarity that was needed. I'll pause real quickly to see if you guys have any questions about this particular review. Okay. All right, so there don't seem to be any questions. So let's go ahead and get into the topics that we're covering for this particular week. So in this particular chapter, chapter 6, the first chapter of this unit number 3, we're focusing on sensation and perception. And so what I'm going to do is just go over some of the key ideas and concepts from the chapter and see if you guys have any questions about that. And of course, the video lectures are already available for you. So hopefully you've seen it. If not, you will see it soon to go ahead and get that out of the way. All right, so in this particular chapter, we're focusing on 2 ideas: sensation and perception. And what it comes down to is when we talk about sensing the environment, that's going to be very critical to our survival. We sense the environment around us so that we can pick up information as to what's going on, so we can make decisions about what we need to do in order to survive as an organism. So we have these specialized sensory receptors throughout our body designed to pick up on stimuli in the environment. We take that information and then we process that information, and that's where we do the perception. So visual information, we use our eyes to pick up the visual information in the environment. It's sent to our brain, the occipital lobe specifically, where it gets processed. And it's there where we actually perceive what we're seeing. We can see what's going on around us. That allows us then to be able to make a response. So if we see something dangerous, we sense the environment, we process it, we perceive what's going on, we say it's dangerous, and then orders can come down from our brain to respond in a certain way to avoid that particular danger. So that's what it comes down to, a key idea. So sensation, perception leads to our survival. So we're able to respond to the environment properly. Now, the other thing that I want to talk with you about, which is key to this, and we talked about it in the lecture, is two basic ways in which we process information. We can do bottom up versus top down. And I'm going to pause to share really quickly to go to another presentation so that I can talk more about that. So pause with me shortly here. Okay, so now you should be seeing a slightly different screen here. And this is the one that I used during the actual video lecture. And what we're talking about here is bottom-up processing. This is sensory analysis that begins at the entry level with information flowing from the sensory receptors to the brain. And all I'm saying here is this: when we are processing things bottom up, we just look exactly what we get in front of us. For example, we have the following. This is an image of something. Now, what this something is what we start to ask ourselves: what is this? So in bottom-up processing, we break it down, trying to process the images, the curves, the line, and the shape. So that's how we process things. We build it up from the entry level. All we're using is the stuff in front of us, the stimuli right in front of us. Now, so your eyes detect the features, your brain pieces it together, and you perceive a picture. What you see is based only on the sensory information coming in. That's bottom-up processing. But with top-down processing, information is guided by higher level mental processes. That's when we construct perceptions by filtering information through our experience and expectations. So in this example, what happens is this. Now we see that exact same image, but now because we have other information surrounding it, so when this image that we saw previously surrounded by sequential letters, your brain expects the shape to be a letter B, and that's what we see, A, B, C. Surrounded by numbers, the same shape now looks like the number 13, 1, 3, 12, 13, 14. So in this instance, what we're seeing is that context is driving your perception. So what we're talking about here is the basic idea that when we are perceiving something, we can build it up with bottom-up processing, or we can use higher level mental processing top-down to come to a perception. And it changes. So the same image, and the key idea is this: the same image that we saw one time is seen as a B, and the other time is seen as a 13. So this tells us to a large degree that perception depends a lot on the context that surrounds it. Okay, so are there any questions about that real quickly? Okay, so the next idea that is key to this deals with what happens when we're sensing something in the environment. So there's this concept called transduction. And transduction is key because what it does, it tries to make us be able to pick up on information in the environment. But in order for us to see what's in the environment or hear what's in the environment, we have to be able to interpret the messages. And because the brain only uses neural energy and neural information, things that it's designed to process, we cannot do that for all the stimulus energy out around us in the environment. So there needs to be a way for us to convert the stimulus energy around us into neural energy, so to speak, that will allow us to be able to understand and to process that particular information. That's going to be key to this whole idea. So we sense the environment, but in order to sense that environment, we must be able to process that data. In order to process that data, it must be in a language that allows us to be able to process it in our brain. That's what transduction does. It converts light waves into a neural impulse. It converts sound waves into a neural impulse. It converts molecules floating in the air that go into our nose. It converts it to olfactory signals that we can process. So in order for us to know what's going on around us, for us to perceive that, we need to have transduction there so that it translates and converts the stimulus energy into some form of neural energy that we can actually use. Okay, now the other idea deals with the concept of thresholds. Now, when it comes to thresholds, the threshold is basically the notion that when are you able to detect something? Okay, a threshold basically says it's defined basically by the idea that you are able to detect the presence of something, for example, 50% of the time. Okay, that means 50% of the time you can detect it, 50% of the time you can't detect it. So if you were presented something 10 times, okay, and 5 times you detect that it was there and 5 times you are not able to detect that it was there, that becomes the absolute threshold for that thing. So absolute thresholds are important. Anytime you can think of this, I think I used this example during the lecture. If you realize after you've come from a picnic that you rub your arm, you realize there's a bump there, that means that you just got bit by a mosquito previously when you were outside, but you did not notice that the mosquito had landed on you and had stuck you. All right, so you were not able to detect it. But another time can be out there out in the yard, and then all of a sudden you feel something land on you. So that tells us that sometimes these stimuli in the environment are so faint that it's hard for us to detect them. Sometimes we may detect them, sometimes we may not detect them. And that really describes what our absolute threshold is. The other type of threshold is called the difference threshold. And this is you being able to determine that there's a difference between two stimuli. So if you have two light bulbs in front of you and they can be adjusted with regard to their level of intensity, they start the same. When is it that you can determine that now one of those lights are different than the other? That's the difference threshold. Again, how that's going to be determined, 50% of the time you're able to detect the difference, and 50% of the time you are not able to detect the difference. And that's the common way that we look at these thresholds. Now, part of this thing about thresholds, they talk about this thing called the signal detection theory. And basically what that comes down to is you trying to detect a signal from noise, from background noise, for example. And in signal detection theory, all they were trying to communicate in that particular section is that your ability to detect a signal will depend on a variety of factors. Whether or not you have a great deal of motivation to detect something, do you care about it? What is your physical conditioning, or have you had a good night's sleep so you're more able to detect that signal or not? And again, the notion is sometimes you're going to be very motivated. So imagine, if you would, someone who is in the Navy and they're monitoring a radar scope and looking for potential threats that may be coming toward the ship. That's a very important job. And so they may be more motivated to be sure that they are focusing and able to detect that signal. Now, if there were someone who was not motivated at all to detect the signal, their attention may wander, they may not focus as they should, and therefore the signal may be very difficult for them. So signal detection theory is just basically communicating the idea that there are numerous factors that come into play whether or not we're able to detect that signal or not. All right. Now, the other topic deals with subliminal stimuli. I'm going to ask you guys, how many people have heard of subliminal before, subliminal communication or subliminal message? I will wait to see if any of you respond to that. How many have heard of that term before? Anyone?
I just got here. What was the term?
Subliminal. For example, we're talking about subliminal perception or subliminal persuasion, subliminal advertising. And basically what it comes down to is the idea that sometimes you can be presented information or stimuli that are being presented to you below your level of awareness, below the absolute threshold. So normally this information should not be available to you. Have you ever heard of anything like that? Anyone?
No, not really.
Okay, so it's going to be new for most of you guys. Now, when it comes to subliminal data, subliminal communication, there's a lot of concern about it simply because it's the idea that people could possibly be influenced and them not know it. That they could have someone communicating directly to their brain, so to speak, and not aware that they're being manipulated in some way. If you already observed the presentation, the lectures, you probably saw some of that already, but just in case you guys didn't, let me call one up real quickly and see if I can show you an example of subliminal. If I have the file still open here, let's see if I can open it. Pause real quickly. Okay, let me go to a new share. Okay. All right, so you should be seeing a blank screen in front of you right now, and I'm going to show you some examples of what we mean by subliminal. Okay, can you guys see what you're on the screen now? The advertisement for some gin.
Yes, sir.
Okay.
Yes, sir.
All right, good. So basically, this is an old advertisement for a alcohol advertisement for gin that you usually would see in some sort of magazine, for example. And basically, in this particular example, some of you have already seen the video lecture, know what the images are. Can anyone see a message that's hidden in this particular image? If you know what it is, go ahead and tell me. There's a hidden message somewhere in there. Can anyone see it? No? Let me see here. Yes. Okay. So someone did say it. So basically, if you look at the ice cubes are spelling out a word, and the word is SEX. And a little bit later, I'll show you, or if you look at the video lecture, you'll see it more clearly. But the idea is that this is what it comes down to. If you are someone looking at this particular advertisement in a magazine, all you're seeing is break out the frosty bottle, you're seeing the images, but your mind may not be consciously aware that there's another message hidden there somewhere. Okay, and the message, by the way, is SEX, sex. And so the idea is that at some level, it's being communicated to your brain or to your mind that this is there, but you're not consciously aware of it. And that is why a lot of people were concerned about subliminal advertising when it came out, that these things exist. because people thought they could possibly be controlled by this type of information. All right, let's see a couple more examples, and then I'll get back to the key lecture items here. Let's see what else we got here. Let's go back. All right, here, you may be familiar with this one or not. Anybody own a copy of The Little Mermaid? If you own a VHS, which is very, very doubtful, a videotape, this is more what we call subliminal graffiti. And Disney is a victim of this quite often, where someone had hidden a sort of a phallic looking symbol in the Little Mermaid cover. It was a big thing for many, many years where they had recalled and all this information. But the idea is that things like this can be hidden and can communicate to individuals, but they're not going to be aware of it. Can anybody understand the significance of why people would be concerned about something like this? I will pause and see what you guys think as to why someone would be concerned about this type of thing.
Yeah, I see the concern, but sometimes I think it's just harmless fun, like the sex with the gin and all that, but I see that there can be some serious cases.
Definitely. One of the things is that often when you talk about the subliminal graffiti, it's done for fun or to poke fun at an organization or something of that nature. In fact, I'm very serious when I say Disney has been assaulted many, many, many times with graffiti in many of their movies, where there are all sorts of images that have been hidden. Today, you can see a lot of them simply because people have the ability to freeze the screen and advance it rather slowly to see some of these images. And it can be harmless fun to some degree. But the concern years ago was that people could potentially be controlled by them, because you are not even aware that someone is speaking to your mind, so to speak. The urban legend one that sort of made people really concerned about it was a book that was written years ago, but it described this scenario where the owners of a movie theater had inserted a phrase or phrases uh, into one of the movies, or the preps for the movie, the things that you see before the movie plays. And it was shown so quickly that no one would be consciously aware that they saw the message. And the message says something like this: buy more Coca-Cola and popcorn. But it was flashed so quickly that you would not be able to consciously be aware that you saw something like that. And so the concern was always that if you're not aware that someone is trying to persuade you or control your behavior, then you can't be on guard for it. And that was the concern that many, many people had when subliminal advertising and all this stuff came out. Now, the long and short of it is that you can be influenced to a small degree when it comes to this subliminal type of stuff, but it's not very long lasting. So there are concerns about it, but the concerns generally are not well founded. And of course, you may have run across people who have subliminal MP3s to help them stop smoking or overeating or something of that nature. And the research done with those also indicate that it does not really work that effectively. So subliminals do exist, but their influence on us are fleeting or not very, very significant. So it's not something to normally be very, very worried about. And one of the reasons that we really don't see a lot of stuff done like this these days is because advertising is so effective as it is. Liminal, let alone subliminal, but liminal advertising is so effective that we don't need to spend the money or time to try to go into secret subliminal types of advertising. And that's what it comes down to. All right. Now, the other key thing that we see on this particular slide deals with another concept called sensory adaptation. And the key thing about sensory adaptation that I want to share with you is the notion that for us humans and most animals, the key thing for us is novelty. And what I mean by novelty, I mean new stuff, things that just pop up that weren't there before. And that's what we're very, very interested in. And so sensory adaptation is basically this idea. You walk into a room and there's a bad odor in the room. After a while of being in that room for 5-10 minutes or so, the odor is not as prominent to you anymore. And what has happened is your sensory systems have sort of adapted to it. In a way, it's no longer relevant to you. Therefore, you no longer pay attention to it anymore. Now, obviously, part of it is that your sensory receptors may have gotten tired. Okay, but at the same time, it does not provide you any new information. But as soon as something changes, as soon as something is different in that environment, then you notice it. So basically, what we are designed to do as human beings, we're really designed to detect things that change in our environment, because that stuff that changes in our environment can be very dangerous to us. And so we want to know what those things are. Okay, so that's the key idea with sensory adaptation. Now, the other thing that we talk about is what influences our perception. So we've already talked to an extent about context, in a way influencing our perceptions with the 13 versus B. But we also see other things. For example, contrast. And what I mean by contrast, if you see something and then you see something else after it, but what you saw before can have an influence on how you're going to interpret what you see next. And I think there's an example. Let me see if I can call up that example real quickly. I closed things out too quickly here. Okay, let me go to a new slide share here real quickly. Okay, so you should be seeing something called emotion adaptation. So how it is that we detect emotions is perception. So when you are meeting your friend and they're giving you really some sort of strange looking facial expression, you are going to go into the phase of trying to interpret what that means. Are they upset with you? Are they frightened of something? What the issue is. So basically what this talks to us about is that our perception of emotions can be influenced by what we see before. So in this particular slide, it says, if you gaze at the angry face on the left, and that's A, for 20 to 30 seconds, and then you look at the center face, that center face will look scared, okay? But if you gaze to the C slide, gaze at the scared face on the very far right for about 20, 30 seconds, and then you return to the center face, it will look angry. So the idea here is that we are going to be influenced by what we've just seen before, okay? And so when we see a more neutral face, we'll put whatever needs to be put onto that neutral face to help us in interpreting what's there in front of us. So the notion is that we need to understand that our perception oftentimes is going to be influenced by a variety of things. For example, whether or not what we've seen before can also have a great deal of impact on what we see now or currently. We can't think of things as being totally in isolation. So for example, if you've had a really bad day and you got into an argument with your boss, for example, at work, and all of a sudden they're yelling at you, your boss is yelling at you, and then you go home, and then your spouse or significant other says something that crosses you the wrong way, you may lash out at them. Most of that lashing out may be simply because you have been sensitized to people attacking you or yelling at you because of your interaction with your boss. So these things can have a great deal of impact on how it is that we perceive events going on in our life. Now, the next idea that we talk about what can influence our perceptions, things like our motivation and emotion can do that as well. So we need to understand that when you are walking, destinations look further away when you're already tired. Slopes look steeper when you're wearing a heavy backpack. Water bottles look closer when you are thirsty. everything sort of changes. And there's also this idea too. If you've ever been on a long journey in the car for hours and hours, and then all of a sudden you have to use the restroom, and you say, well, I'll wait till I get home before I use the restroom. Okay. And as soon as you get into your neighborhood, and as soon as you pull into your driveway, can anybody tell me what normally happens with your psychological perception? Do you seem to have to use the restroom even worse then? More so as soon as the closer you get to your home? Does it seem like it intensifies, or is that just me? I'll wait to somebody respond.
Yes, it gets worse.
Yeah, it gets worse. And so the idea is that's a psychological thing to a certain extent. Nothing's really changed, but all of a sudden we have a greater urgency at that time. And so the notion again is that our perceptions of things change even internally, of things that's going on with us inside of us. So these things are very important to understand, that sensation and perception, how they work together, and also how our perception changes based on a variety of factors, sometimes outside of us and sometimes inside of us. Now, the next thing we talk about in the chapter that I'm going to go over real quickly here is going to be vision. And vision is thought of as the most important sense for us. It's the sense that we rely on the most, okay, more so than any other sense. And what it comes down to, we have electromagnetic waves in the environment, and you can see about the description of that in the textbook and also in the lecture. And these electromagnetic waves are of different sizes and lengths and different characteristics, and that's how we are able to see. So we have to have specialized receptor cells, sensory receptor cells, available to us to be able to detect those particular types of wavelengths. And that's what we have in the eye. So the structure of the eyes we see laid out here. We have the cornea, which is that outside of the eye, slightly curved, bent to help provide focus. So the light beam goes through there. It goes through that small hole, the pupil, which can adjust in its size to let more or less light in. And the thing that's actually being adjusted is the muscle called the iris, and that's where we have the color of our eye, be it brown or blue or green. That's the muscle that's colored, and that changes the size of the pupil. And so the lens is directly behind all that. And it's the lens that's held together by these muscles, and it can change the shape of the lens so that it can reflect the image of whatever that we're seeing out there in the world to the back of the eye. And it's the back of the eye is where the magic happens. That's where we have the retina. And the retina is the item that contains all of the rods and cones, which are specialized sensory receptors for vision, rods and cones. And these rods and cones are sensitive to these types of electromagnetic waves. And it's that allows us to turn it in to neural impulses that our brain can actually understand. Now, a couple of things I want to point out so we understand them is that first, we have this thing called the fovea, which is one of the arrows is pointing to that. And the rods and cones are different. Rods, there are lots of those, about hundreds of millions of rods, and only a few million cones. Rods are good for seeing in twilight, peripheral vision. Cones are good for seeing color and having really good focused vision. And because of that, the fovea is where we see most of our cones located, because that's where you're going to have your clearest vision, directly center of the eye, central focus. So when you want to look at something that's really, really tiny or really small, you hold it up so that you can hold it right directly in front of your eyeball, line it up with that fovea, so you will have the clearest vision possible. That's the fovea. Now, the peripheral vision is going to be controlled by the rods. And so those things are going to be somewhat gray. They don't have color capability and those types of things. And that's going to be key to our survivals, that sometimes we'll need to be able to see in the dark or close to twilight conditions. The rods allow us to do that. We want to see something really clear and focused, and we need the detail. The cones allow us to do that. All right. Now, the other item I want to point out is this thing called the blind spot. The axons that form the optic nerve are coming from the rods and cones area from the retina going out, so it can go to the thalamus and then on to the occipital lobe. The blind spot is what it says it is, because that's sort of like the cabling leaving the eyeball. There's no rods and cones which are physically allowed to be there, because all you have is cabling. So if you're looking at something and they're moving it across your eyeball, there's going to be a point where it will just vanish from vision. And that's that image going across on the retina. As soon as it goes across that blind spot, that item that's going across your vision will disappear, because there are no rods and cones present for you to interpret the electromagnetic waves anymore. And then once it passes the blind spot, it will reappear, because then you have the rods and cones again. So the blind spot is something that is legitimate and real. It's part of the way our eyeballs are designed, that we have these things that can happen that way. So again, vision is one of the senses that we are most relied upon. We see a lot of things. Excuse me real quickly, I apologize for that. That there's an issue when it comes to our ability to see things. Our ability to see things as it goes across that is going to be greatly stopped by this particular blind spot. So vision is something that we rely on quite a bit. We have a lot of systems in our brain to rely on our processing of visual information. Now, in the lecture, they'll talk more about color vision and show you a little bit of example about the opponent process theory that's behind color vision as well. So be sure to make note of that when you see it. The other vision that is key to us is going to be our ability to hear, also referred to as audition. Okay, so basically we have these sound waves, air pressure changes around us, and these things are designed to allow us to be able to pick them up from the environment, channel them down to the ear canal, so that we can then process this information. So what we have here is the vibrating air or sound waves on the outer ear, passes through the auditory canal and to the eardrum, which I'm sure most people are familiar with, this little tight drum inside that ear canal, and it will vibrate, okay? And then it goes to the middle ear. We have this vibrating eardrum, and then the chamber between the eardrum and this thing called the cochlea contains these 3 bones, and these bones are designed to amplify the vibration that's coming from the eardrum. So we have the hammer, the anvil, and the stirrup are the names of these bones. And what they're doing is just making the vibrations from the eardrum pass along so it can go to this thing called the cochlea. And the cochlea is a bony fluid-filled tube in the inner ear that contains these specialized nerve receptors. So in the inner ear, you have these things. So we have this basilar membrane. It has these hair cells on top of it. And as the fluid moves back and forth, certain hair cells will bend. And it's this bending of the hair cells that will cause a neural impulse to occur. And so this is where the transduction occurs in our ability to hear. It turns these sound waves into a neural impulse. When the hair cell bends, it fires a neural impulse that's sent through the auditory nerve all the way to the auditory cortex of the temporal lobe, where you are now processing the words I'm actually saying. So wherever you are now, you're sitting in front of your computer or on your phone, you may have earphones in or not, or a speaker that's letting my voice come out to you. That's sound waves. It's going into your ear now, vibrating the eardrum, moving those bones of the middle ear, which then jostle the fluid in the cochlea, which then bend the hair cells, which then ignites the neural impulse, which travels along the auditory nerve that goes to your temporal lobe, and then you're hearing the words coming out of my mouth. That's the way it works. Now, there are other structures too, which we'll talk about real quickly here in the inner ear, the semicircular canals and the vestibular sacs, which will be more apparent later. But this is why when you have an infection of the ear or a really bad cold or flu that's influencing or impacting your inner ear, your balance will be off, because those inner ear systems like the semicircular canals and the vestibular sac, they're going to be very important to us maintaining our balance and knowing where our body is. And so when those things are out of whack, we'll be really wobbly on our legs because our body's not giving us the proper information about where our body's located. All
I have
right.
a question.
Sure.
What will happen if the person is deaf, like he can't hear or anything? Would that somehow mess up his balance by any way?
It shouldn't, simply because your ability to hear is going to be based on certain types of failures. So it could be that there is something that is preventing mechanically stuff from getting, the waves from getting into the inner ear where it can move those hair cells. Now, we see people have that issue all the time. That's why they have a hearing aid. Okay, but if there are other factors that are at play as to why somebody may be deaf, it could be something dealing with the temporal lobe itself. So that would not affect any of those inner ear systems like the semicircular canals or the vestibular sac. Their balance would be just fine. That make sense?
Okay.
Okay, so it just depends on what type of thing going on. But obviously, if for whatever reason somebody was born with a malformation of those particular items, yes, they would have some issues with their balance if those things didn't develop properly. Okay. Okay. All right. So that gives us the idea of what audition is and how the basic process of audition works. Now, the other sense that we want to talk about real briefly, and we won't touch on this that detailed is going to be our sense of touch. Now, sometimes we forget it, but the largest organ of our body is our skin. Okay, and we don't think of it that way, but it is. And the sense of touch is actually a mix of 4 distinct skin senses, and they are pressure, warmth, cold, and pain. So that's really all that our skin can really sense. Either it's pressure, it's either warmth, it's either cold, or it's pain. Now, every other skin sensation that we have are going to be variations of those 4, period. That's just the way it is. Now, let me give you a really example that I gave in the video lecture is pressure and cold. And pressure and cold is simply this. If you have pressure and then cold, it hits your skin the right way, does anybody know what perception you will have of pressure and cold when it hits your skin the right way? What will you experience? What will you perceive, even though it's not really going on? Wetness. So if you have pressure and cold the right way, if you've ever touched like a cold door handle or something, and then you pull your hand back because all of a sudden it felt wet, but it's not wet at all, is because pressure and cold will be perceived oftentimes as wetness. Okay, so again, we can see those types of things easily available to us in our day-to-day life, and that tells us about how different combinations of these 4 distinct senses can be perceived differently. Now, the other key thing I want to talk briefly about is pain. Pain gets a rap sometimes, a bad rap sometimes. Pain is oftentimes seen as an issue, but pain is really important that we do have pain. Does anybody know why it's important that we have pain?
It helps us like detect danger.
Exactly. We have pain because that is a warning sign. Our body is trying to tell us something's not right, something's wrong. And sometimes it can be very subtle pains, but if we don't pay attention to them, they can be particularly dangerous. For example, you're sitting in your chair in a really, really long lecture. Let's say you have a 4-hour class and the instructor wants to keep going through the class, and you've been sitting at your chair for 3.5 hours and you're getting antsy. Now, what you normally do as you're sitting in your chair is you're moving around all the time. You're not standing perfectly still because your body is saying, I'm not comfortable, shift, and you shift. Your body says, I'm not comfortable, and you shift again because you're listening to the pain. Now, if you didn't have anybody, if your body was unable to detect pain, could it cause a problem? Yes, indeed. It would cause a major problem because you would not have those signals telling you that you need to change something in your environment because it's causing damage to your body. And some individuals are born without the ability to detect pain. They don't experience it. Those individuals normally don't last a long time because they injure themselves too regularly and they don't know how to change their environment when things are happening in the environment that would cause normal people who can experience pain, to change something in their environment. So pain is our friend. We don't like it, but it's important to experience it because it's telling us when there is something actually wrong with us. So sensory receptors respond to potentially damaging stimuli by sending an impulse to the spinal cord, which passes messages to the brain, which interprets the signal as pain. Now, obviously, we can control pain, and we talked about this in the previous chapter when we talked about certain types of drugs. We can take certain drugs to control the perception of pain. Okay, but at the same time, we could have an epidural. Has anybody ever had an epidural before for pain treatment? No one? Okay, so basically what they're doing there is they're
What do you
basically,
mean by epidural? Like
go ahead.
it's like rehab or something like that?
So I didn't catch that last part.
Like what were you asking? I didn't hear.
uh, have you ever had like an epidural? I mean, for example, that's usually when they put something onto the spine, for example, and what they're basically doing is blocking the signals that go to your brain that says that you're experiencing pain. Okay, so
Oh,
for certain procedures, they will do that because all you're doing now is you're just stopping the messages going to your brain. Because basically, if your brain does not get the message about there being pain, you don't experience it. Okay, and so they just block that
yeah.
message. All right, so the notion is that pain is our friend. Just need to realize that. Now, the other thing I want to add real quickly here is that many factors play into our experiencing of pain. For example, let's say if you are around your friends and you hurt yourself, do you cry in front of them? You may be more likely not to because you're around your friend. You may, try to walk it off. You don't want them to see you cry or to show weakness or something of that nature. So pain is a personal thing. Some people can tolerate a lot more than others. Okay, certain cultures may say that you don't show your uncomfortableness or pain when you are going through types of things because it might not be something that is proper for a particular culture. So there are many factors that will come into play when it comes to our ability to experience pain. So pain is not an absolute, it's somewhat relative at time, depending on what culture you're part of and your experiences and things of that nature. Even to be honest with you, pain may be a gender thing too, to a certain extent. For example, if you have a little boy and a little girl, if the little boy skins his knee and the little girl skins his knee, some parents may treat them totally differently depending on, whether they're a boy child or a girl child. They may hug and comfort the girl more than the boy. The boy may get rewarded more for, not crying so much. There's my little man, that type of thing. So these things can be affected a great deal by one's culture and also how you were raised to some extent as well. Any questions before I move on? Okay. All right. Now, the next sense that we talked about is somewhat different. This is the sense of taste or gustation. And this is a chemical sense. So far, we've talked about a physical sense and about sound waves and electromagnetic waves or light waves. Now we're talking about something that's more physical in a sense, more chemical, definitely. And this is taste. And it involves several basic sensations. And your sense of taste can be influenced by a variety of things. What food that you have learned to eat growing up, what part of the world you grew up in, what's part of your diet, what your expectations are, your perceptual bias. All these things will influence the things that you eat and your preferences for taste. But definitely one thing that's really important about our taste is that it is important for our survival. Okay, very important for our survival. Because basically, when we taste certain things, they may give us a warning. For example, when we taste something that is really bitter, that could be a potential poison. Taste something that's really sour, that could be something that's very toxic. Okay, so the idea is that these things, these tastes that we have, they are there, obviously to excite us so that we eat food so that we can survive, but at the same time, they're there to help us to survive as well. Now, the basic idea is that we have a variety of taste receptors in our mouth. Most of them are going to be located on our tongue. But the key idea is that for us to taste anything, we need to have whatever we're trying to taste in a liquid solution. And that's why we salivate. When someone puts a nice plate of food, our favorite food, in front of us and we happen to be hungry, our mouths will start to salivate. And that's in preparation for us to eat so that we can taste the food. And in order for us to taste the food, whatever we eat, let's say we're eating a hamburger or something, that hamburger needs to be chewed up and then floating in the solution that's your saliva or whatever drink that you're drinking with it, so that it can land properly on the taste receptors in your mouth, so that it can be able to taste these variety types of things like sweet and salty and sour, bitter, whatever. So the notion is that that's the way it works. Now, we usually eat at least 3 meals a day, and what it comes down to is that because we use our mouths so much to eat, that we usually will have a replace out our taste receptors on a much more regular basis because they get damaged and things of that nature. So we have a whole new batch of them from time to time. It also should be noted too, if you've already been around someone who's a little bit older than you, and you see that they tend to put a lot more salt or pepper on their food, or hot sauce on their food, for example, the reason behind that simply is that they may have done it less so when they're younger, but more so now, is because as we get older, we have fewer taste buds. Okay, and so our ability to taste is going to sort of start to decline a little bit as well. All right, so that is gustation, or our ability to taste. Now, the other chemical sense that we have is smell or olfaction. And we have these airborne molecules or fragrance. They are floating in the air, and they go into your nose. Okay, and these molecules in your nose, they go to the receptors that are located in your nasal system as well. As you sniff, they go to the receptors, and the receptor sends messages to the brain's olfactory bulb, and then onward to the temporal lobe's primary smell cortex, to the parts of the limbic system usually involved in memory and emotion. It registers in the area not far from the brain where we receive information from our sense of smell, where it can also interact with taste. Now, the key point is this. When you smell something, no matter what it is that you're smelling, molecules of that something needs to go into your nasal cavity. Whether you're smelling a rose or something less pleasant, the molecules are having to travel up into your nasal cavity to those receptors, travel to the bulb, and then through the olfactory nerve, and then to the proper area of the brain where it can be processed. Now, it should also be noted that if you've ever noticed before, if somebody makes your favorite dish because you're sick, maybe you have a cold or a flu or what have you, and you taste the food, does the food taste the same as it normally does when you have a cold? That is a question.
No.
Does anyone know why? Any ideas are welcome. Why does the food not taste the same when you have a cold?
Because of your taste buds?
In a way, it's going to be because of your taste buds. But one of the things that we need to understand too is what taste really is. What you perceive of taste is not just your taste buds. It's also your smell. So your perception of taste is involving not only the stuff that you are physically tasting in your mouth, but also the aroma or the smell of the food. So when you have a cold or a flu or something that's messing with your nasal passages and you no longer have the ability to smell, or your ability to smell has been deteriorated greatly, then the food will not taste the same to you as when you were completely healthy. You could smell the food and taste the food in your mouth at the same time. Your perception will not equal the perception that you had when you are healthy as when you have this cold or flu, because you no longer can smell it. Now, an example would be this. I use this, I believe, in the video lecture as well. If you had a potato and an apple and you cut it into a cube, so you have a small cube of apple and a small cube of potato, and they are basically of the same type of texture, and you give it one to a person, both to a person, and you block their nose with a clothespin or something so they can't smell anything, and you tell them to taste it, they would be hard pressed to tell you which one is the apple and which one is the potato, because most of what you're sensing or tasting as the apple to a large degree is going to be the smell of that apple. So we see a great deal of interaction going on between our taste and our smell. They're very much integrated. A little bit later, in chapter that we'll be covering in this particular unit on memory, we'll talk about smell and memory and emotion, because of this path that the olfactory nerve takes that goes through the limbic system, where we have memory and emotion centers located. We'll see that there's a special relationship between smell, memory, smell, and emotion a little bit later. All right, and so the last senses that we talk about, we're just going to talk about them real briefly here as we start to wrap things up. We talk about body position and movement. So kinesthesia is the system for sensing the position and movement of individual body parts. Okay, and what this is basically saying is this: when you are doing something physical, for example, running upstairs or running down a football field to catch a pass, you need to know where your body parts are. You need to know where your feet are, your legs, your arms. Well, this is the part of the system of the body that allows you to do that. You may not be fully aware that it's giving you all this information, but imagine, if you would, if you did not know where your feet were. Now, a few years ago, I was on some medicine, and it caused something called neuropathy, when I didn't have full sense of where my feet were all the time. And it revealed itself to me because I would be walking in the hallway and I kept bumping into things. I kept bumping into the wall of the hallway, because as I was doing something else and not paying attention, I didn't get proper feedback from my feet, and I just veered off course, so to speak. So kinesthesia is going to be very important. You don't notice it until there's something wrong with it, but you always have some indication of what your body parts are doing as you're moving. Okay, and that's what kinesthesia is doing for us. The vestibular sense is the sense of body movement and position, including your sense of balance. And this is the one that we were referring to earlier. You know, when you have some inner ear thing going on, your sense of balance may be disrupted. You may have what is called vertigo. Okay, that you're standing, but you're standing still, but the world seems to be all wobbly. And that's because the systems in your inner ear are causing some problems because they're not working well. Now, there's going to be a bunch of hair cells and these type of little crystals in that inner ear, and they're sort of telling you when you're balanced. Okay, and so when that system is out of whack, you can be all wobbly on your feet because you're getting all sorts of input from your body telling you that the world is spinning. It's not spinning, just your software, so to speak, is telling you the world is spinning, and you have no ability to stop your feeling that yes, the world is indeed spinning, and you may have to lose the ability to stand upright. But there are all sorts of things that we are learning and continuing to learn about how our body operates and how we are able to detect body position and balance and all this type of stuff. And it's one of the reasons why oftentimes when they are sending people up into a space station to go live for a few months up in orbit around the planet, they're always trying to find out how being weightless, with no gravity influencing the body, how do we live with that? Because the body is designed to be obviously within gravity so that we have weight, okay, as opposed to being weightless. And so they realize too that if you're up in space for too long periods of time, your bone will start to get weaker and all that type of stuff. So we're learning a lot as we do things to understand the limits of and capabilities of the human body. So the next slide that I'm going to go through now is going to be a summary of all the senses. Are there any questions right now? Okay, so what we've seen in this particular section, we've seen the sensory systems, the sources where they're coming from in our environment, and the specialized receptor cells that we have there give us the ability to detect them. So with vision, we have light waves striking the eye with that retina and the back of the eyeball with the rods and cones. We have hearing, the sound waves striking the outer ear, the thing that we refer to as the ear, the pinna, which is the curved little thing that helps to focus the sound waves down into the ear canal, ultimately going to the cochlear hair cells in the inner ear, where those hair cells will bend and then fire a neural impulse that we can ultimately perceive as words. Touch, pressure, warmth, cold in the skin, where we have these skin receptors that can detect pressure, warmth, cold, and pain. Taste, chemical molecules in the mouth, where we have the basic tongue receptors that are located on the tongue, but we have others too located within the mouth as well. Smell, the chemical molecules that we breathe in through our nose, where we have millions of receptors at the top of the nasal cavity. And then the last two that we covered, position and body movement parts of kinesthesia, where we have any change in position of the body part interacting with vision. Okay, the sensors in the joints, tendons, and muscles, so that we know where our body parts are and what they're up to. And then finally, we have the vestibular sense, movement of fluids in the inner ear caused by our head movement and body movement. And we have these, again, these hair-like receptors and the semicircular canals in the vestibular sacs that tells us when we're balanced. I mean, if you really think about it, if you were, God forbid, kidnapped and put in some sort of, by your friends for some sort of prank, and they put you someplace, you would be able to, for the most part, be able to detect where gravity is coming from for the most part. I mean, it may be difficult to do, but you could, because it's the pull, the slight tug. Okay, and so these systems are there to allow us to be able to say what our body is doing. Now, all these things together, what they're doing is they're telling us about our environment. These sensory systems, what their key role is to tell us about our environment so that we can perceive what's going on, so that we can properly respond to whatever issue or danger that's there in the environment for us to do, so we can respond in the proper way. So that is it for the key items I want to cover for today. Are there any questions or comments that you have before we wrap things up? And if you haven't, please make sure that you did send me a message on chat so that I know that you're here. So when I start giving out some bonus points for attending these sessions, you can get some. All right, if there are no other questions, you guys are free to get out of here. I'll be ending the meeting shortly. All right, you guys have a great weekend. Bye.